Okay, so here we go. Now, this lecture is about research methods primarily. And even though this week you'll be reading about statistics, I'm going to mostly focus on research methods. And I want you to think of this as an introduction to social science research methods because you can go on and take a much more in-depth course about this. But I just want to give you a preview because I believe that everyone should know a little bit about social science research methods. And here's why. I want you to be empowered to question things that are presented as facts. When someone says there's 45% of this and there was a significant increase of that, I want you to be able to go, huh? And look a little deeper at how they came to that information. I also want you to be able to defend your uh, things that you understand to be supported by good evidence. And I want you to construct your own knowledge, what you know about the world, based on more than just your own experience or the testimony of others. Essentially, social science is about trying to look at the world beyond anecdote, beyond experience. But interestingly about psychological science is it's actually looking for empirical evidence about measurable trends in experience, in how people feel, but it's looking beyond one person's story. So, just to get started, we want to be thinking about what is science, right? You've heard it your whole life. You've taken science classes in um, uh, high school, but there's a certain philosophy that goes along with science that it's important to emphasize. And there's certain there, how do you know it's science? Well, it's easier to know when it's not science. And so here are some things that science has to be in order to be science. That includes it needs to be dealing with things that are observable. You need to be able to count it. You need to be able to measure it. Maybe you put it on a scale. Maybe it's a rating system, but something about it needs to be observed. It needs to be able to be predictive. So in science, you do more than just observe, although that's part of it. You also form theories that predict what will happen. So uh, there's this element of time in science. So, like you've been observing what's happened in the past, what's happening in the present, but you form a theory about what will happen in the future and test it. And that makes it science. It's the testability. That's this next point. You can test whether your prediction happens or not. I mean, you can make a prediction about lots of things, but if you can't test it, it's not science. For example, like one of the big debates is, religion or beliefs in God versus science, and they aren't the same. I'm not, uh, I'm not going to knock anybody's beliefs. They have a really important role in life. They can be more true to people than science is, but I'm saying right here, it's a different type of truth. It's a truth that's felt and that can't be tested. That's why it's not that science and God are incompatible. It's that you can't prove God with science because you can say God is going to give me a blessing, you know, uh, and that's pretty unpredictable. Even if you get a blessing, you're not sure that God gave it to you. But anyway, like, I don't want to prevent you from having important spiritual beliefs or whatever, because they're very important. But I just want to let you know they're different, they're distinct, and they're different ways that human beings are. Also, science is falsifiable. Like, that's one of the big reasons why, like, you can't prove God doesn't exist. You can come up with all sorts of evidence that suggests that, yeah, there might be a God there. But one of the reasons why people say it can't be proven scientifically is because you can't prove that this was or wasn't caused by God. It's not knowable. So that means that that type of knowledge exists in a realm that isn't science. The other aspect of science is that it's replicable. If you predict something, you can predict it'll happen again. Like, because there's this element of luck. And that's something that we'll see when we go more into how you design studies. is how you deal with the fact that chance, you could say, I'm going to predict that a green-headed dog is going to walk through that door in the next 10 minutes. And it could come true, but I need to be able to replicate it in some way or have a theory about why it happened and when it will happen next in order for it to be scientific. So I'm giving you an extra credit this week about why falsifiability is so important, because I kind of recognize my own inability to express to you how important it is. So it's extra credit, you don't have to do it, but there was a philosopher called Karl Popper who identified the difference between science and pseudoscience. And that key difference is whether your theory can be falsified. So the video that I'm offering you in extra credit will give you like a better feeling for why that is so important. Now, just to get started, we're going to talk about 3 different types of research in social science. And those 3 types of research are observational, correlational, and experimental. So like here, I'm showing you, like I'm using it with just an example of breakfast, right? So when we're doing observational research, we're basically asking, did something happen or didn't it? How often does it happen? So you're counting how often. How many people had this experience? Again, you're just counting it up. What different types of behavior tends to occur in a certain situation? Now you're classifying, right? All of that is observational research. So an example of an observational research question would be, what do people eat for breakfast? Can you ask people? Can you count it? Can you observe it? Can you classify it? Yes. So fruit, eggs, toast, meat, all sorts of different ways. You can just observe, what do people eat for breakfast? The next type of research we're going to talk about is correlational. Somewhat hard to explain, pretty easy to understand, but I struggle to explain it. It's, do changes in the levels of one thing correspond to changes in the levels of another thing? And that corresponding could actually be going in the same direction. As one thing goes up, another thing goes up. Or it could be as one thing goes up, another thing goes down. What would an example of that be? As income goes up, a student's absenteeism might go down. As health goes up, a worker's absenteeism might go down. So this is a correspondence between 2 different things. And so if we use this in our breakfast example, we could ask, when people eat breakfast or don't eat breakfast, these are just an either or, do they tend to be more or less cranky? Does eating breakfast tend to be does more breakfast relate to less cranky? Does less breakfast relate to more cranky? So that's correlation, because we don't know if maybe people who eat breakfast are just less likely to be cranky as people because they take better care of themselves. There might be some cause besides breakfast that might be associated with crankiness levels. So we can't be sure with correlation. We just know there's a relationship. Or people who skip breakfast, maybe they're so driven and intense that they have to get stuff done. So their goal orientatedness is the thing that makes them more cranky about things in life rather than the breakfast. So there could be these other causes. When we look at correlational research, we don't know cause. Correlation does not prove causation. Now, experimental research is designed to identify cause. What causes what? Experimental research is when we purposely make changes in the levels of one thing to see if it causes changes in the levels of another. So for example, if we randomly assign some people to not eat breakfast and others to just do what they normally do, then we would see at the end of the experiment whether one group, the experimental group who were restricted from having breakfast, whether they're more cranky or not. There are many different types of experiments, but that's a basic experiment. We're going to go over these a couple of different times in different ways, but I'm going to now go into more detail about observational research. It's about watching, counting, classifying. There are different types of observational research. For example, a case study. What's a case study? It's when you look at, like, let's say, a 22-year-old college graduate and how he manages his pandemic response. What does he do with his friendships and his relationships? What does he do with his work and looking for work, and what does he do with interpreting the risks? We may go deep into one case. Another place where case studies are very often used is in business. You study one business case of, like, a company that started a sporting goods line and started marketing specifically to environmentally minded people. We might learn all sorts of things about what that company did, but we really aren't learning about what people do in general. We're not learning about what causes what. We're just observing what one case did in one instance. That's a case study. Also, in observational research, something that's really important is just understanding the frequencies of things. So, how many people are killed by police? How does it differ by race? What are the factors associated with it? How many people in poverty are killed by police? Does just being poor increase your chance of being a victim to police violence? How do we understand these things? And one way that we understand what's happening in our world is just counting. How often? How many? What percent? What observational research does not indicate is causation. It does not. So I just have some examples. For example, when Eileen took hydroxychloroquine, her COVID-19 symptoms cleared up. Like, that's one case that may have happened. That's awesome, but it doesn't show whether her symptoms were caused, her symptoms clearing up would have happened anyway, if she'd taken it or not. Or when Rico took aspirin, his COVID-19 symptoms cleared up. Because a person could be suffering from COVID-19 and take aspirin all the time, and then they go away. Is it because the aspirin did it? We don't know. It could be just that he got better because his own body helped him, etc., etc., etc. I want to also just alert you to understanding what a testimonial is. And that a testimonial, it's not false. What I mean by that is when I say, when I did this, it happened to me. So, for example, when I started taking vitamin C, I started losing so much weight. Now, that can be true. And I may be entirely convinced that the vitamin C caused me to lose weight. But that isn't it. It's only evidence of what happened in my life. And my inference and assumptions about causation are ill-informed. I don't actually know what caused it. But I can have a testimony and plenty of belief about what causes it. But it we are prone to making mistakes about these kinds of things. And that's why we have research. That's why we do research, so we can understand these better. One great thing about testimonials I want to emphasize is that they can lead to really interesting research questions. Because in social science, we are not studying a science that's done. We are studying a science that's in progress. So whenever, as you go through this class and you find findings that are interesting or surprising, and maybe they run counter to your experience, don't assume that your experience is wrong. Maybe there's something about your experience, like your age or your gender or the culture that you come from, that was never accounted for in the original research. So as we understand how these methods happen, we become empowered to make questions, even about research findings themselves. And sometimes our own personal experience, or that of our mother or a friend or our what have you, may inform research questions very fruitfully. Going a little bit deeper into correlational research now, this is really about connecting the levels of two different things. And I want to just talk to you about the difference between a positive correlation and a negative correlation. So here I have a few charts that help to express what a correlation is. Um, a positive correlation is one where, like for example, this is maternal smoking and fetal defects. If you have more maternal smoking as it goes up on this y-axis, you have more fetal defects. It goes up on this x-axis. Here you have exam scores and class absences. As you have more class absences, you have lower exam scores. That's a negative correlation. And so that's expressed with this correlation coefficient. If it's a positive, for example, R equals 0.80, that's as one thing goes up, the other thing goes up. If it's a negative correlation coefficient, as one thing goes up, the other thing goes down. And that's how that is. So I want you to think for a second about these correlations. Age and height. Are age and height correlated? Yes. Between the ages of 0 and 17, you could say that age and height are correlated. So it kind of depends, right? But once you're 20, are age and height correlated? I don't think so, right? How about this correlation? Criminality and intelligence. Are criminals stupid? Are stupid people more likely to commit crimes? Actually, there is no consistent relationship between the level of intelligence and repeat offending. What about religiosity and income? Do people who have more faith or say that they're more religious, are they richer? It's possible. But guess what? It's a negative correlation according to this Pew Research. As income goes up, belief in God goes down. Does being richer cause lower beliefs in God? We don't know. It's just a correlation. We don't know, but that's something that's been a correlation that's been found. What about loneliness and mortality? Actually, those are positively correlated. High levels of loneliness is associated with a greater likelihood of death among older adults. So you can see how correlational research can sort of inform you about how things are connected, but not necessarily how things are caused. I'm going to say a word here too about surveys. Surveys are really common in our world. Essentially, a survey is a method used to obtain information by asking many individuals. Like if I just want to know about you, I'll do an interview. But if I want to know about the whole class, I'm probably going to do a survey because I don't have the time to ask each one of you individually about how you feel about stress in my class. But I might do a survey about it, right? It's a useful way to gather data from many people in a systematic way. So being systematic is very important in science because we need to be able to do it exactly the same way the next time. So we can have some degree of confidence that we're measuring the same thing or roughly the same thing. But surveys are limited by certain factors. For example, when you ask somebody, "Did you eat breakfast today?" they may answer in a way that makes them look good. They don't want to be seen as a person who skips breakfast, for example. So they may say yes. Or let's say they may be a little bit overweight, like me, and they don't want to be seen as somebody that eats all day long. And so they may say, no, 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 I don't eat breakfast. So we don't know if they're answering accurately. Also, there are other things. I'm not going to go into them, but you can read about them in the book. For example, the order of wording the questions or the response options that you get. There are many. If you ever get a chance in the rest of your college to take a course about writing surveys, you will learn a lot about even just how to talk to people and how to form your questions. It can be a very valuable skill to understand. But now let's talk about experimental research. Experimental research is about controlling one level of a thing to see if it causes changes in another thing, right? So, for example, in experimental research, we manipulate one variable in a group without manipulating the same variable in a control group. And then we compare the subsequent level of an outcome, blah, blah, blah. This is a boring definition. I want to keep going. Experimental research, importantly, it does imply causation if you do it right. And one of the ways to do it right is to have an experimental group and a control group. The experimental group gets the treatment, the manipulation, and the control group doesn't. So in our example, if you're in the experimental group, no breakfast for you. And if you're in the control group, just eat what you normally eat. And then, if we do what we talked about earlier, we'll measure your level of crankiness after a week, say. I want to show you here the importance of a hypothesis. Am I going to show you here? Basically, this chart that I'm showing you right now is an example of the different elements of an experiment. So here, I'm going to form a hypothesis, which is a prediction of what I'm going to find after I collect the data, that time constraints will increase frustration level, right? If you feel pressured by time, you're going to be more frustrated. How do I test that? I'm going to randomly assign people to an experimental group or a control group. I'm going to tell the people in the experimental group, please solve this puzzle, but you only have 3 minutes. And I'm going to tell people in the control group, please solve this puzzle, take as much time as you want. Then afterward, I'm going to measure their frustration levels. I'm going to compare the frustration level in both groups. And if my prediction is true, then I find that the experimental group has higher frustration levels than the control group that had no time constraints, I am going to be able to conclude that time constraints caused increased frustration. That's the basis of an experiment. I'm going to say very quickly a little bit about the scientific process, and we're going to move through it quickly. There's a lit review where you understand what else has been out there. Actually, I'm going to go into this. This is sort of the overview of what I'm going to talk about in a second. And you can look at this in more detail if you download the slides. But I want to go through this in terms of what are the components of a study. And a lit review basically gives rise to a good research question. So science assumes that there's probably some research on this topic out there somewhere. And a good lit review goes through and says, what's being researched out here? So in here I have an example. I may have a feeling that stress is related to academic performance. So I may ask, is stress related to academic performance? I may even suspect that higher the stress, the lower the academic performance, but it's too soon to tell. I'm going to start doing my research. I'm going to see what other studies have been out there that have looked at these two things. And I may find that there's so much out there that I need to get more specific. So maybe my research question becomes refined, and I start to and it becomes, are challenge appraisals related to completing college? So if people are more prone to interpreting a potentially stressful event or demand as a challenge, are they then more likely to complete college? So that's why you do the lit review, because if you don't see what's already been studied and you just study whatever's on your mind, you're not contributing to science. You're just doing the same thing somebody's already done. So that's why the lit review is so important. It helps you refine your research question. Now, a hypothesis. I want you to know what a hypothesis is. A hypothesis is a testable prediction about the outcome of a study. It's a statement based on a theory and evidence made before the data is collected and analyzed. A good hypothesis clearly states the predicted relationship between measurable and observable variables. A good hypothesis operationalizes or makes a variable measurable. So, for example, we started out with a research question. Are challenge appraisals related to completing college? Well, how do we measure that? So we may yield this hypothesis. Students who use challenge appraisals will be more likely to complete a 4-year degree within 6 years. So do you see how I needed to refine my interpretation of what I meant by completing college? Because you might complete college if you complete your 2-year degree, and that's great, yay. But I need to have I need to have one definition so that I can measure it accurately and consistently. Also, a study has what we're calling variables. I've already started mentioning them, but there's the independent variable. That's the thing that you can actually manipulate, or that's the thing that you're watching change or that you make change. And then there's the dependent variable. That's where you're seeing if it's in an experiment, the dependent variable is caused by or impacted by the change in levels of the independent variable. So the independent variable moves independently to itself, but we researchers are manipulating it or observing it. But the dependent variable is dependent, theoretically anyway, on the changes in the first variable. So in our hypothesis where students who use challenge appraisals will be more likely to complete a 4-year degree within 6 years, the independent variable is the challenge appraisals, more or less, up or down, use them or not, right? And the dependent variable, which is completing the degree as defined. Another important part in your research is basically your sample design or your randomization of groups. So who is it that you're researching? The sample is what we call people who participate as part of the research. We call them participants. We call them subjects sometimes. A good sample is evenly representative of the population being studied. So if I want to make a conclusion about adults in America, I'm going to have a sample that is representative of adults in America across different age groups and ethnicities, etc. But I can also do research that could say be just among college students. I can even be more defined and say, I just want to study community college students. Why randomization is important is because when we assign to different groups, it mitigates the problem of sample bias, which we will talk in a minute. So here we see ourselves choosing Chaffey College students, randomly selected. Like if I went and I just only did a survey on you people in this class, my students, it might be biased because you may answer in such a way that people who take psychology, they may share something in common, right? And you may answer differently because you're interested in psychology than, say, math majors or engineering majors or people who think psychology stinks and would never take it. So that's why we have to think about, is my sample representative? And then when I talk about that, I would acknowledge the limitation of my sample. If I do research on you, my psychology students, I would want to acknowledge that these findings are possibly only applicable to psychology students in a community college. And then this slide, I might not go into it now because I don't want to take you on a forever lecture, but I just want to show you how the study design, observation, correlation versus experiment I go through in this slide, and you can see another example about how those things are different. And lastly, this is the only thing I'm going to say about statistics. So let's say we observe, let's just look at this. Let's say we train some but not all students in challenge appraisal, and we assess whether their appraisal increases or assess whether their their challenge appraisal increases and whether they complete a degree. And then we compare those who didn't get the training. Let's say we do that experiment. In order to analyze it, to do a statistical analysis, we need to make sure that the difference that we see in one group, the experimental group versus the control group, didn't happen by chance. Because any difference, any group is likely to be different. And so what we're doing when we do statistics is we're trying to rule out the likelihood that this happened by chance. We're trying to be, when we have like p is less than 0.05, we're trying to be more than 95% certain that this would not have happened by chance. So I'm going to now quickly talk about bias. I want you to know about experimenter bias, which is when the experimenter, this should say experimenter, really wants to get certain result or they expect a certain thing to happen. How do you solve it? Because they may like subtly measure something in a certain way, or they may interact with the patients that they're studying in a certain way, and they may actually influence the result of their study. You solve it by doing double-blind studies. You solve it by having, say, researchers involved who don't even know the hypothesis of the study. They just have instructions on how to interact. You solve it by having placebos, by having people think that they're getting a treatment, but don't. Another bias is ethnocentrism. This is when experimenters only look at data from their own culture, or when they interpret in ways that are limited by cultural assumptions. You can solve it by having cross-cultural samples. You can solve it by having a culturally diverse research team so that when you're interpreting the results, it's not just through your one lens. Other types of bias can happen among participants. There can be a sample bias. For example, like we were just talking about, when you only sample for one group. And then we just talked about that. So the other type of bias is participant's bias. This is when a participant might change their answer so that they look good, or they may change their answer to give the researcher what they are looking for, or they may change their answer because they're expecting certain outcomes. I gave you a pill. Oh, I feel better, right? That is a very common effect. That's actually called the placebo effect. How do you solve participant bias? Anonymity, confidentiality, double-blind studies, temporary deception. So there are things that researchers do to protect themselves from doing research with these biases. And they're very important to remember so that when you think about research being presented to you, you can look for these things and question research based on these things. And very briefly, I'm going to talk about ethical considerations. When we do research with humans, it's important that humans give us their consent, that they have a voluntary participation, that they're choosing to engage in this research with us, that we have limited deception, that we don't lie to our participants, and and if we sometimes do, because it's necessary perhaps to reduce the bias that they may give us, there's a debriefing, and that we keep the confidentiality and even better, the anonymity of our participants. If they tell us something, its confidentiality is sacred among researchers and among professors as well. So I'm not going to go into these examples of unethical behavior. For example, torture at Guantanamo Bay was psychological insight was used to actually cause torture. That's unethical. The Tuskegee experiments, the Milgram experiments, the Stanford experiments, these are all things that we will actually talk about later, but they're problematic. And the final thing to understand is when you go into psychology and you do psychological research specifically, there is a code of ethics put forth by the American Psychological Association. So if you're seeing yourself as someone who's becoming a psychologist, familiarize yourself with this code of ethics because this is what's being expected of you. And I show you this so that you feel good about the field of psychology, that we're not all Guantanamo Bay torturers. In fact, that goes against the ethics of psychology. And that as a field, as a group of people, we have standards that we expect of each other. So I hope you read these and find them interesting. With that, this went a little long, but I hope you enjoyed it, and looking forward to the next lecture.